Hello, welcome everyone. I'm glad that you're here. If you can hear me, if you can see me, please write me on some comments. Um, we'll be talking today about event sourcing, of course, that's not surprising. And we'll be also talking about EventStoreDB, and that's also not surprising. But for some folks, might be surprising that we will be doing Java and Spring Boot, because I think that's our first webinar done in those technologies. My name is Oskar Dudycz. I'm currently working as a developer advocate at EventStore. And besides that, I'm a still active developer. Um, I have experience for over 14 years in our industry, and I went the whole journey from a junior, senior, tech lead, architect, and manager before joining EventStore. Hello, George. Hello, Gerard. So yeah, let's start. That's all about me. Let's start by having a look at this black and white photo. If some of you are fan of boxing, then for sure you recognize the person at the top. This is Muhammad Ali, and at the bottom lies Sonny Liston. And this is really old photo because it was made in 25th May 1965. And what I'm showing you is the end result of the fight that just lasted 1 minute and 44 seconds. And this is a good example of what's event and what event means, because event is a fact. It's something that happened in the past, like this fight happened in 1965. Each event gathers a specific information about something that has happened. So in this case, we have information about who was fighting, so Muhammad Ali and Sonny Liston, how long the fight was made, and also other information like what was the avenue, etc. And the really important thing about the event is that it's a fact, so you cannot change it, you cannot change the past, but you might interpret it differently. So for sure, even looking at that picture, you can see that Muhammad Ali, the same fact, the same result of the fight, interpreting much different than Sonny Liston. Of course, if Sonny can't interpret anything at that moment. And this fight was also known, and the punch that Muhammad Ali gave to Sonny was known as a phantom punch, because no one saw that. So till this day, there are discussions and interpretations whether that was all set up or that was a real fight, because no one saw the punch that Muhammad Ali gave. And the other important term in event sourcing is event stream. Because in event sourcing, each business operation should result with the event. And event stream is an ordered sequence of events. So we can build a story of a specific object, for example, a shopping cart. We can see what precisely has happened during its lifetime. So at first we see that shopping cart was open, then a product was added to it, then another one, then we decided to remove one of the products, and in the end probably we will get a shopping cart confirmed event, and then we can take it from there. So in event sourcing, each entity in the classical approach is you can see it as an event stream. So event stream in fact is an identifier of the ID and sequence of the facts that we recorded about it. So we are building like a story, like a process of the living entity. And the important thing about event sourcing and event stores like EventStoreDB is that they, in general, most of them at least, allow to have also a a history of the operations in the system. So in fact, if we have a look on those shopping carts, then those facts are probably registered in parallel. But then when we are registering them one by one in our database. So this is a great thing because we can also diagnose and see precisely what has happened in the whole system. So we can build the history of the whole system. And let's just start with the event sourcing. So something that you might be interested the most. So let's have a look at briefly at the architecture of event sourcing systems. I'm joking, that's not the architecture of event sourcing system. Maybe that one. No, that's not the one. So if you see in the internet or some other talks that someone is saying that this is an event sourcing architecture, then you might stop probably listening or just wait and ask some question whether this is in fact true. Because event sourcing is not a pattern that the global system pattern. You should think about event sourcing in the scope of the specific module. So if you are starting to use event store and event sourcing as a single one, you can compare it to using like a whole huge database shared between other microservices, etc. So event sourcing is not a revolution. That's something that I would like to show you in this webinar. So you can do a point implementation like for the business module that gathers the most complex domain. You can use event sourcing, but you can also integrate that with other approaches. So what's event sourcing about? So let's have a look on the example of the shopping cart that I started in the previous slides. So if we are recording new events, then you will see those events on the left side, and on the bottom right side you will see the classical approach into it. So when we are recording cart initialized, then classically we would add a new record. In this case, it would be we would generate some ID, set a product count to 0 and status to open because no products are there. When we are adding new product, then again we are recording new event in event sourcing, which gathers a specific information like a price, what computer game is that, and in the classical approach we would probably update some record, like for example update products count in the shopping cart entity. Then when we are removing product, then we are in event sourcing, we are again creating new and appending new event. And this is an important phase to understand, because in the classical approach, if you were overriding the previous data or you were deleting, that would be even worse, then you would already lose business information. You would lose information about the product added, because see, we are again zeroing the number of products, and you cannot see by looking at that record whether something was added in the meantime or not. And so if we continue to record new events, then each business operation creates a new fact, and in the classical approach we are just updating and making on-point changes. So you might say that, yeah, okay, but no one is just modeling a shopping cart by just a single table. And so let's have a look at the example when we included the product items table. And in the middle, you will see the example how the event payload could look like. So if we have initialized event, then we could put probably in the data like a cart ID when it was initialized, and in the classical approach, that's a new record. When we are adding new product, then see, we are not updating anything in shopping cart table, so our main aggregate table, but we are appending and adding new record into product items list. And if we have removal of the product item, then again, having separate table is not helping us anyhow in seeing whether and losing data and losing the business context. That's really important. And if we are adding, then see we again added business information. And of course, some potential solution to that is not doing the hard delete, but doing soft delete and marking those product items as deleted. And then we could see somehow the also deleted products. But even now, we can see that it's hard to know precisely how the specific change is mapped into the specific table structure, because in shopping cart might be or might not be updated, even though we are changing the shopping cart. And in classical approach, if we want to diagnose what happened, and then we need to understand and check on multiple tables. And if we are using normalized database structure, then we don't have just 2 tables, but probably 4. And why is it so important to not lose data nowadays? Because currently the storage is relatively cheap. We are not living anymore in a 20th century, and we don't have Amiga 500 or Commodore 64. We can the storage is really cheap, but the information is priceless. For example, information about the product that was removed or the shopping carts that were left can be used for enhanced analysis and knowing precisely what has happened in which sequence people were adding product to shopping cart. Then even in such a classical and non-complicated example, you can see and get much more insights when you have that information. So let's have a look on the payload and focus on that. So some of the information in the payload are the same for all events. We can name it metadata. One of the metadata is the stream ID, the position in the event stream. So as you can see, each event will get a new position auto-incremented, because we need to somehow know whether in which order those events appeared. We might have some timestamp, we might have some another metadata or even custom metadata, and we have data. And data gathers only granular information about something that has happened. So as you see, if we have product added, then we probably don't need to know anymore for which user this event was recorded, because we will know that from the cart initialized event. And we have information about the product, etc. And in the confirmed, we don't need to have information about all the products that were there, but just information about when it was confirmed and maybe by whom. So let's reiterate how the classical flow in event sourcing looks like. So at first we are getting a request classically like in a web API, no difference for the classical approach. Then that's the main difference with the classical approach. So the first thing after doing the validation, we should get all the events that were already registered for the specific stream. If we are creating new one, then there will be 0. If we, for example, have opened shopping cart, then we will have single event. If we added new product, then we would have 2, etc. So we take all of the events that were registered for the specific entity, and then we are applying those events one by one on the default representation. So for example, we might call just a default constructor to get an empty object. And after we apply all of those events, then nothing's different in the business logic. We are just running the whole business logic, and as a result, we are appending new event to the stream. And that's the second difference. So the first one is that we are retrieving state from events because that's where the event sourcing name comes from. So we are treating events as our source of truth. And then we are running business logic in a classical way. And the next step is to just store another event. So some may say that, okay, but wouldn't be reading a few events be too slow? Then I can guarantee you that event stores are optimized for loading those events. And as you saw on the previous slides, events should be relatively small, and event store are optimized on getting multiple events from the same stream. So it's not a big deal to just get a few granular events. It shouldn't be much bigger overhead in the transport than the regular approach. Of course, we need to have a proper design, and it's important thing in event sourcing is to keep streams short and to include the temporal aspect on modeling. But if we model that correctly, then think about how your entities in your current system, how many times are they changed? My guess is that like at least few times. And even 100 times or 1,000 events for event store to retrieve shouldn't be an issue. And so event sourcing in general is, you might say that this is just a storage pattern. So we are just appending events and retrieving them and building the state from them. You could use a relational database or any other storage like a Mongo, Elastic, etc. Because event sourcing is not saying anything how you should store events. It's just saying that you need to retrieve state from events, and you, as a result of business operation, you should store yet another event into the stream. So it's not just it's storage agnostic. So there are tools that are using event sourcing and build it on top of relational database, and they are fine. Still, if we would like to have the full potential of the event sourcing storage, then probably we would like to have it optimized directly and natively for event storage. So like that, we could store those structures in a disk like any other database is doing, because any other database is eventually storing that as some files on the disk. And this is where event store comes from, because I think that event store is the first one. It was the first event store, so the category of those databases are named like that, so event stores. And EventStoreDB is just database that is natively created and designed for storing and processing events. So okay, I promised you that you will see some Java code and Spring Boot code and EventStoreDB. So let's have a look on the code. And I really encourage you to leave some comments and leave questions. I might not be able to answer them directly, but even if I don't answer them while I'll be showing the code, then we can go back to that at the end of a webinar and clarify all of those questions, concerns, etc. So let's see how we could model events. So I will be using the Java 17. So how many of you is using already Java 17 or even Java 18? Because there is a newer version. So the first part, that the first thing that from latest Java version I think is really cool is the sealed interfaces. So we can say that all of the shopping cart events are implementing this interface. Oh, nice, George. So you probably already know what I'll be talking about. So we are declaring here a set of events that our shopping cart will have. So the first one is that we are opening the shopping cart, and I'm also using record, because as I said, events should be immutable. We shouldn't be able to modify them and to rewrite the past. And event store doesn't allow you to even modify them. So in Java, in latest Java version, I think from 14, you have records which are immutable objects that when you create them, then you won't be able to change them. So we are also reflecting our assumptions directly into the code. So again, we are defining here all of the events that shopping cart might have, and we are using sealed interface to limit them. And we have the first one, then we have another one, so product item added to shopping cart, then accordingly removed, and in the end confirmed. Yeah, 8, unfortunately, it's not allowed. So I hope that Java 8 will evaporate at some point, because there is so many new cool features in the latest Java versions. But yeah, let's go back to our code. So you don't need to use records, you don't need to use sealed interfaces. You can model them as classes, but I think that records are a good matching for the event sourcing premises, because immediately we have a compiler won't allow us to update and modify our events, and it's just a shortened syntax and much slimmer, which is also nice, because we don't need to just create a bunch of files and go between them. So as you see, there is a shopping cart ID that is correlating all of those events, but the rest is already specific for those events. So we have client ID for shopping cart opened, for a product item added or removed, we have which product item, and then we have information about confirmed. So let's have a look how we can model in event sourcing our data structures, so our entities. We again can use records, because the certain state that we will be doing, I'm showing right now the more like a functional approach, so where we have a kind of anemic model and we are breaking the entities and data model from the business logic. I will show later on another approach using aggregates. But here we are again using sealed interface, and we are defining that our shopping cart can be either pending or confirmed or cancelled. And using those sealed interface is cool, because for all of those operations, like so for pending shopping cart, we can add new product, removed, confirm. But for example, for confirmed or cancelled shopping cart, we should not be able to add new product items or confirm or cancel it again. So we can also use records and those structures to model strictly how we would like the certain state of our shopping cart look like. Of course, it's not needed. You don't need to have immutability. You don't need to use such entities. But I think that it's really useful and it's good modeling practice. Once we have that, we can also, for example, define whether our shopping cart is closed. So this information will be useful for our business logic. And for that, we can check whether it's an instance of confirmed or cancelled shopping cart. We can also calculate the status based on those types. So all those are the goodies that are coming in the latest versions. But still, you could ignore all of those other statuses. You could use like a nullability here and just create a unified shopping cart class. That's up to you. Event sourcing is not enforcing that, but I think that in general, immutability gives better predictability, and it's good to represent our our business logic also in our code structure. But let's focus on the merit, and let's see how we could build the shopping cart out of events. So we can define a method. Let's call that when. We could call it apply. This method is defining that if we have a current state, then how this state will change when we apply another event on it. And this is the place where the sealed events are extremely useful, because then we can say that if we get shopping cart event, and as you see, this event might be one of those events that we defined here, then we can do a switch and we can do a pattern matching based on the switch type, based on the event type. So if we are getting a new, if we have a shopping cart open, then that means that we should create a pending shopping cart and putting their shopping cart ID and client from the event. Then when we are also setting the product items list as empty. If we are getting a product item added to shopping cart event, then we need to just use the data from the current. So we just sending shopping cart ID and client ID that we got from the previous step, so from here. And we are creating a new collection with the new product item. Accordingly, for the remove, we are removing and passing that collection to the pending shopping cart. If we are confirming shopping carts, then we are not changing either ID, client ID, or product items. We are just setting the confirmation date, and for cancellation, we are just setting cancelled at. So we are just defining how we should apply and what's the result of this apply to our class. And we will be calling this method for each event in our registered for our shopping cart. So please tell me if that's clear or I should explain it more. And until I get some questions, let's have a look on the test that is showing how that could look like in practice. So let's say that we have some client with ID and we have some shopping cart and we have such product. We have shoes and we have t-shirt. And we have already registered for the specific shopping cart following set of events. You should know that from the slides. So shopping cart was open, then we added shoes, t-shirt, and then we decided that no, we don't need those shoes, they are too costly, so we removed them. And in the end, we confirmed this shopping cart. So how to get the current state of the shopping cart from those events? So at first, we need to create an empty shopping cart using the default object. And empty is nothing spectacular. We are telling that the first state of shopping cart is that it's pending, and we are doing some ugly hack here by providing null because we don't expect that state to be usable anyhow. Because if we get back to our tests, then for each event that were already registered for this specific shopping cart, we will be calling this when method or apply method, depending how you name it. So we will be for the first event, we are sending the empty shopping cart. We are sending the first event in which we expect that this is shopping cart opened, and as a result we are returning the pending shopping cart with the information about the ID, client ID, etc. And then we are getting next event, so in this case product item added to shopping cart, and again we are applying that on the previously set shopping cart state. And then as a result, when we go through all of those events in our collection, then we are getting the end state of our shopping cart. So I hope that's clear. If not, then feel free to share any concerns or ask questions, or even just say that yeah, it's okay. And let's have a look on the other way of how we could model our state. I would say it's more classical way. So how you would deal it, maybe probably that could even compile in Java 8. Maybe some bits would not, but in general, that's how you could do it in the classical approach using also aggregates. Some people also prefer to have a rich model and centralized business logic within the specific class. So it's up to you to decide. I'm just showing you the typical ways of how to build the state from events. So in this case, we will be using exactly the same structure of events. So we again will use the sealed interface, defining all of the events for the shopping cart. But our structure will be much different. So we will have a unified object containing all of the data about the shopping cart. So we won't have like a certain states like we had before, so different classes for different shopping cart states, but we have just a unified version which contain client ID, product items, shopping cart status. In general, it's like a unified union of those states that I showed you before. And in aggregate approach, you should expose all of the methods, all of the business logic as a public methods of the aggregation. So we will see later on when we get back how the split would look like in the functional way. But in aggregate, we are just putting also business logic together with our state. So that's one of the biggest advantages of using aggregate pattern. Let's have a look how the aggregate object is reconstructed, because that's quite critical. So we have a set of information. We will get back to that later on. Let's focus right now on the ID, because our aggregate needs to have ID, so it's good to enforce that. And we also have the most important thing that is for now, is that we have abstract method when that takes event and just update the state. So let's have a look how the implementation of the when method would look like for our shopping cart aggregate. So we are taking the event and we again benefiting from the sealed interfaces and doing the pattern matching, but here we are not generating any new immutable objects. We are just adding and we are just setting the information in the specific aggregate. So this aggregate is mutable, but it's only mutable internally. So either when we are reconstructing the state, calling this method when for this object each time we are getting an event, or by calling some public method that updates, that do validation and then updates the internal state. So that's another approach. So we could use this private method and this empty class to generate an empty object, and then run the for each logic that would call for each event this method, and as a result build the state. So records are fine, but sometimes if we need like an extremely tight performance thing, then recreating those objects shouldn't be an issue, but still might be an issue. So it's up to you and your preferences which approach you choose. I wanted to show you how you could do it. And George is saying that I could use some undefined value that says the same thing as Java devs. We kind of hate nulls. Yeah, I know. I also hate nulls, but yeah, as I said, I'm just this is just a hack and marker that I would like it to fail ugly, because that should never happen. And if that happens, then it's really bad. So I'm totally fine with getting null pointer in this particular case. But of course, we could define some specific default on or empty object statement. If we go back, we could probably, if we get here, then we could probably define something like unknown shopping cart and treat it as the default one. So then we don't have nulls, but then in each place we would need to support it because compiler will complain if we didn't use it. And as I said, I'm just, when we have this ugly hack with the empty object, then I just assume that this should never happen in the real life. And I would like it to fail as soon as possible. So sorry, George, for just using nulls, but I hope that at least it's more clear why did I do that. And okay, let's get back. And as we are here in the shopping cart and more functional way, then let's see how we could run the business logic for our business operations. So let's have a look. We could, in general, I like to structure my code base based on slices and based on the business logic. So as you see, I have a shopping cart module. I have my shopping cart entity and events, so those things that are central and related to shopping cart, but then I'm not splitting it into technical split, but I rather prefer to keep it also business wise. So for example, adding product item would have at least a dedicated class or at least a dedicated folder, like typically. That's how I like to do stuff. And here, for example, we can define as a command, we can also use record and define that if we are adding product to shopping cart, then we are saying for which one, which product, and then we can also provide expected version, but that's for the later on. So what we are doing here in the handle method is we can define how the business logic should look like for the specific command and the specific shopping cart. So as I mentioned, when we got the state from events and we build our entity, the current state, then we can use it in our business logic. And there is not much difference between the classical approach and event sourcing. As you see, I don't have any events here. I'm just using the entity class. And then I'm doing some validation. So here I'm checking whether this shopping cart wasn't already closed. Then I can also inject to such function like external dependency. So for example, a service to calculate the pricing, and out of the information from my command, so which product item I would like to add, I can also calculate and make the pricing for the specific product item and add it to shopping cart. And the only difference between the classical approach and event sourcing is that as a result, I'm returning an event. So if I'm using the functional approach, that's extremely trivial because I can just return it as a result of this function. And that's pretty cool because it helps in the testability and predictability. Because see, this is just a pure function and we can run our test in saying that for such specific shopping cart state and for such comment, I expect to get a following event. And if you'd like, you can even mock the external dependency. And some people are saying that event sourcing is hard to test. So, but I don't know what's complex in such tests. In fact, I think that event sourcing is highly testable and it's really helping in the diagnostics, etc. So we can define business logic for other commands in the same way. For opening shopping cart, it's a bit different. because we are not passing the current state because we don't have such. We are just passing comment. This is just a dummy logic. I wouldn't even call it logic, but we are here. We don't have any business condition to not open the shopping cart. For canceling, it's a similar stuff. We are just verifying whether it wasn't already closed. So for example, it was confirmed or closed. And then if not, then we are just returning a new event as a result. So that's how that would look like in a functional way. So I'm really curious, what are your thoughts about that? Do you found that strange or that's nice? Feel free to share feedback, and let's have a look on how we would do it in an aggregate approach, so more classical approach. So in aggregate, as I mentioned, we would define a method for each of the business operation directly in the aggregate class. So that gives us encapsulation. We have more control around what's happening with our data. So it's we are just enforcing that no one can change this aggregate out of the internal logic that is kept together. So as you see, there is not much difference in the business logic part or validation part. We are doing exactly the same thing, and in this case we are not returning event as a result. We are just enqueuing this event as a result, and then that gives us the benefit that such aggregate, if we use it outside of our in the classical way, then we won't see from the outside that this is even sourced, because we are just defining the public methods, some state, etc. There is no information in our logic, no big revolution here. So what enqueuing does, it just storing this event in an uncommitted event list. And this uncommitted event list we will use later on with this method dq to get those events and store them in the event store. And what I didn't tell you before, it's also fine to return more than one event. So that's why I'm keeping here a collection, a queue of events instead of single event, because you might be doing more than one operation during the business logic, or your business logic might result in more than one event, and that's totally fine. In majority of cases you would get just a single event, but you might have also get more than one. So let's maybe go finally to some production ready code and see how we can use this uncommitted events and how we can integrate all of what I show you with the EventStoreDB. So let's start with the getting events. I defined an aggregate store, which is kind of repository pattern. So it's just saying that we expect aggregate with following set of events and with following ID type. And for getting the current state of aggregate, what we are doing first is we are getting all the events for the specific stream ID. Let's get back for a moment to shopping cart, and we have here a method named let me just find it. Yeah, we have map to stream ID, because EventStoreDB by convention keeps the IDs of stream as a string, and it contains from the two major parts. The first one is called category, so it's like an aggregate type of or entity type of our entity. So it's in an EventStoreDB nomenclature, it's category, so you can distinguish what's the type of this specific stream. And then after dash, you have the specific shopping cart ID, because you can have multiple streams for the same aggregate type. Like you can have multiple shopping carts. So if we get back to aggregate store, then here we are mapping the shopping cart ID to the stream ID, and then we are calling get events method. And get event is calling the read stream method from event store. We can pass here stream ID. We can pass more parameters, like whether we would like to read it forwards or backwards, whether we would like to read it from the specific position. But by default, we should get all of the events from the stream. Then we should make sure that this stream in fact exists. If not, then maybe return optional. And then we need to deserialize events, because event store is keeping those events, can keep it in the JSON format, but it can keep it also in the binary format. So we need to show how we would like to deserialize that. And as a result, we are getting a list of event, or just an empty optional if stream didn't exist. And if we are having get method, then if we got an empty events collection, then we are returning empty, saying that there is no record with such ID. And if it is, then we are calling the for each method that you already know, and calling the when method that we passed here. And I'm using here functional interfaces from Java. That's also quite new, but not totally new. So I'm just saying that I need to provide information about the when method and how I would like to use it. Yeah. So in the functional way, it will look the same, but we are just calling another method. So we are just calling the when, as I mentioned, we need to pass it here. So we are again in the aggregate and aggregate store. So we can use this get method in, for example, to define method get and update. Get and update will take a functional interface that will define what we will be doing with the following entity ID, because we need to load it, and we are also passing the expected version, because important thing is that EventStoreDB guarantees a strong consistency on writes, and also guarantees read your own writes. So all of the things that you would expect from the major database for the write logic part. And it also guarantees the optimistic concurrency. So you can provide expected version, and if the stream in the database is not at the expected version, then it will throw an error and the event won't be appended. And George, you have a question. Is it available on GitHub for later reference? Yes, it is. There is an event store samples repository, and there is also my private one, event sourcing JVM. So you can check our GitHub. I will also link that later on after webinar under description or as a comment. So all of the things that you see here, they are already in our repositories. So feel free to check them and create an issue and send a feedback. So again, let's get back. We are getting entity using the getID method, getById that we discussed before. We are running some business logic, and as a result of this business logic, we are storing a new events. And how we are storing those events? In aggregate example, as I mentioned, we need to take them from inside, from the aggregate. So we are getting those events by using the queue uncommitted events which again contain all of the events that we added as a result of our business operation. So for example, opening shopping cart, we enqueued even shopping cart open event. It will land in an uncommitted events, which we use later on to get the events to store. An important thing about event store is that it also guarantees atomicity if we are appending multiple events to the specific stream, to the single stream. It doesn't guarantee at that moment between streams, but it might come in the future. So as a result, we are appending events. We can use expected version as, to make sure that that we are making our business decision based on the latest state. And in general, that's all. And if we have a look on the functional approach, then it's more or less the same. We need to provide also the when method because we don't have it in the base class, but we are calling it the same way. So instead of calling that on the aggregate here and just changing its internal state, we are just assigning a new entity state to some temporary value. For adding, it's a bit even simpler because our handle method is already returning event, so we can just serialize and store that event in EventStoreDB. And for get an update, it's exactly the same, besides the fact that we also are getting event out of the handle method. So let's see how we can glue that finally into promised Spring Boot application, because we are getting really close to that. Or in fact, we are already here. So we can define a shopping cart service. This will be our application service that will contain all of the handling for the commands that and for the logic that we will be doing. And it will be orchestrating our API calls with the business logic, because we would like to keep our business logic technology agnostic. Because let's have a look again on, for example, adding product item to shopping cart. As you see, this is just a pure function. It's extremely testable. You can run unit tests and make sure that it's working fine. And then you can glue that with the infrastructure code. So our entity store that we defined in the shopping cart service. So the shopping cart service can expose the method in the functional approach that add product item, that is taking the command which contains information of what we intend to do, and we are just wrapping the business logic with those wrappers that I showed you before. So we are saying that if we are adding product item, then we would like to get the current state of the shopping cart, and when we have this current state, then we would like to run logic defined in this function for the specific command. And this is also example how you can inject external dependencies, because we are injecting that through the constructor, and that will be automatically injected by the Spring Boot dependency injection container. And all the other methods looks exactly the same, besides opening, because here we are using add method because we don't expect the stream to exist. So we are just opening shopping cart and then storing event. Let's have a look on the aggregate approach. And let's find the reference. So here it looks exactly the same. We have also shopping cart service, but we are using aggregate store here. And we are just saying that if we got the current state of the aggregate, then we would like to run this method for this aggregate. So for example, add product item with the params that we provided from the service method. And this is also example that you don't need to have comments. You can still have the methods and that looks exactly the same as in the classical way. Yeah, George, thanks that it looks so clean, because in general, in my opinion, event sourcing is helping to build clean applications, because having immutability and having the history for the same set of events, you will have exactly the same result. And it's even much easier to create a generic logic like this get and update, because we will always have the same result of the business operation, a new event. So we don't need to care, at least at this stage. Eventually we will, but we will discuss later on about stuff like foreign keys or multiple tables and how to map them, etc. So that's also why I'm so into event sourcing, and why I love this approach, because it just helps to build applications that are closer to business and make them in a predictable way. So yeah, that's so happy. I'm really happy that you also noticed that. So do you have any questions about the write model part? I will show how to connect that into controller to just make it full sample. But in the meantime, if you have any questions, then feel free to ask them. So here I'm showing you the Spring Boot controller. So see, like the classical annotations like validated, request mapping, etc. We can still create an application like that. So controller doesn't need to know that we are doing event sourcing. No events here, and no event sourcing. We are just calling the service, which internally also doesn't know anything about events. It's just calling the either aggregate store or entity store. So this we could use the same pattern for the classical approach, and you will learn that we are using event sourcing only when you find and check how the aggregate is implemented or how your business logic is implemented. So George has a question. So the event store and aggregate are different implementation. Yes, that's correct, because I wanted to show you the most popular approach of handling event sourcing. So the functional way, which I'm getting more into that. That's why I show you as the first one. And the other one is more like a domain-driven design way, so using the aggregate pattern. And you can find both examples in our repositories, so event store slash samples or Oskar Dudycz slash eventsourcing.jvm. So you can check them and compare them and find, I would even encourage you to play with them and see what's more aligned with how you are doing stuff. So again, controller, classical Spring Boot controller, we are injecting shopping cart service. Let's just show you that I'm really using the shopping cart here, the Spring Boot here. If you didn't know, then see like Spring Boot beans. I'm just saying that I'm injecting this aggregate store. How am I creating it for the specific entity, and also how I'm setting up this shopping cart service. Of course, we could use component annotations, but in general, I'm not a huge fan of annotations. So if I can live without them, then I would prefer to not do them. Okay, so let's go back to our slides for a moment. If some questions about the write model part will pop up, then feel free to raise them. But I would like to also show you how you can build your read model. Because if we would try to, for example, get a shopping cart list, so get all of the shopping carts that are currently open, like an admin view, then getting all the events for all shopping carts would not be optimized. even if event stores are optimized for getting multiple and many events, then it would still not be ideal. So for that case, we can use the projection pattern. What's the projection? And projections are just different interpretation of the same information, the same fact, the same set of events. So as I mentioned, this fight between Muhammad Ali and Sonny Liston is interpreted totally differently by any of the boxing fans. And even here, as you can see, those are different pictures showing the same fight, so showing totally different perspective. And we should think about the projections in exactly the same way. And projections are typically used to build a materialized view from events. So we could put those materialized data, this flattened data, into some storage that is designed for querying, where we don't care much about having the whole history. We are just intent to get the latest state of the particular entity. So for that, we can take a set of events, like all of the events from our stream, and build the record, the flattened classical record, and store them in, for example, relational database, Elasticsearch, or any other database. So as I mentioned, it can be from the single stream, but it can be also from the multiple streams. So we can, for example, build a user cards dashboard where besides shopping cards data, we will also keep the information about the, for example, username, etc. So, we are just taking events from here and from that, and we are joining that together and building the materialized representation and store it somewhere. So how to do that? Classically, and the most popular way, is to apply all of the events one by one. And this approach is called left fold, because we are taking something from the left side and then we are applying on the right side. So as on this picture. So we are taking card initialized event, and then we can create a new record in the database. And if we are adding new product added, then we can update products counts, or we can create a new entity in the product items table. So we are just making the on-point change based on the information we have in event data. And if we have confirmed, then we can just update the status. George is asking if those will be continuously changing representation of fixed point in time. Yes, they will. So we will, because typically in applications, when we are querying for data, most of the cases we are expecting to have them the current state to be operational. So for example, to get current state of shopping cart, or go to the list and click somewhere and go to the details view, and then just run the logic, etc. So for that case, we can keep just the current state, and that should be fine. However, if we would like to keep also like a human readable history, then in this case that I presented here, instead of updating a single record, we could in theory just create, for each of the events, we could create yet another record in like a cards history table, where for each event we would have just a human readable interpretation. But so projections in general are just interpretations of the set of events. So we are taking some events, interpreting them, and storing them somewhere, or getting the result out of that. Can you request what was the representation day ago? That's a question for George. Yes, in the right logic, if we are querying events, we can also query events and say that we would like to get events only from the particular set on this particular time. So get all the events before this time, and then run the business logic or run debugging, etc. That's extremely useful for the diagnostics. But here we are discussing here more like a read model side. So the classical side where we need to query more than one data. And if we build also the representation, like I mentioned, for example, creating new record on each event, then we can also just query this data in the specific database. George, if that doesn't answer your question or didn't make enough clear, then feel free to say that. I will try to explain that better when we get to the code. I hope that this would make it more clear. So as I mentioned, we are building the query and read model representation that we can use in the query side. And what's, in my opinion, the power feature, the best feature in event sourcing in general, is that single event can modify multiple read models. For example, event that product was added to shopping cart will update product's availability, will update the shopping cart details view and also dashboard. And why is it powerful? Because as I mentioned, on the right model, we are focusing on what's the best way to run the business logic and how to store fact of what has happened. And in the read model side, we can split those implementation, because then it's help on reducing the cognitive load. So how much we need to know at the certain point of time of our development process. So at first we can focus on the right model, and then knowing what events did we got and what facts did we recorded, we can decide to update and change the representation. Also, at the beginning, we might just have the shopping cart table, but after that, if we already have those events recorded, then we can build a new views like products availability, user dashboard, etc., based on the events that we already have recorded. So that's really great, because quite often I'm getting questions that, for example, someone was using some queuing technology like Kafka, and then they are saying that, yeah, it would be great if we could got all of those events that we recorded, but then the retention policy came and erased all of the facts. So if we are using event sourcing and we are storing durable the events in the event store, so the database, then we can benefit out of that even in the future to get more insights, to build a new business features without even doing the migrations. Of course, not always that's that's looking so great and so easy as I'm saying right now, but at least we have we have that option, and we have just more tools and more benefits. So it's not like it's extremely revolutionary, because in the end we will need to create a similar stuff, but it helps on working effectively and just giving us more options, which is kind of cool in my opinion. So projections can create other events, and event store projections, if you get EventStoreDB projections, if you get to our documentation, then they are in fact transformations. So they are taking event or set of events and appending a new event, because in EventStoreDB you have two database structure, event and event stream. So as I mentioned at the beginning, and in EventStoreDB the projections are asynchronous, because it's not like projections have to be asynchronous, and some frameworks allows to make synchronous. So if, for example, you are using relational database, then you can update tables in the same transactions, and and update read models within the same transaction. However, in the end, you might be facing the scalability issues and performance issues. Those majority of event stores are just embracing that we have the eventual consistency and updating asynchronously. And in EventStoreDB, that feature is named subscription. So EventStoreDB will send you a push notification that you can subscribe and get information of what you can do and how you can decide what to do with this event and with this information. And Gerard is saying that storing all events forever is easily fixed with Kafka, but not getting all with a certain ID back easily. Yes, that's correct. You can set retention policy to infinite. However, Kafka, it's a great tool, but it's a great tool for moving data from one place to another. And that's what the tool, in my opinion, best for and made for. So from streaming information from one place to another, but it's not a database in a sense like we would expect. So it doesn't, as Gerard said, we don't have API for saying that give me events for the certain stream. So for example, give me all events for the shopping carts. We can subscribe to those events, but we won't get them. Kafka also don't have the optimistic concurrency. So you are never sure whether you are making decisions based on the latest data. And because you don't have this read API, then you cannot do stuff like I show, like get all events, run business logic, and get the strong consistency on writes. So it's something that is critical, in my opinion, for the business logic, because we want to have it right. In Kafka, of course, there are some workarounds, but as always, the question is whether that's the right tool for this job. So I would say that, in my opinion, doing event sourcing is Kafka. It's not possible, at least in a canonical way. And it's better to use tools that were natively built for that. Of course, Kafka is great for moving data from one place to another, but it's not a database. So even with EventStoreDB and with subscriptions, you can forward that to Kafka and you can integrate those tools. And I think that they are playing pretty well together. So for example, you can use Kafka for integration between the microservices and EventStoreDB as a storage for event sourcing pattern, or at least for those modules that are using event sourcing patterns, because for the others you might be still using relational database, etc., for those that are more cradish. So I hope, Gerard, that you agree with me, and if not, then feel free to send me feedback. And let's move on. And projections are predictable. So if we get the same events for the same logic, we will get exactly the same result. But if we get for the same set of events and we had a bug in the projection logic, then as events are our source of truth, then we could even decide that we would like to rebuild this model based on the events and the new logic, new fixed logic of projection. So we can do it in two ways. I mean, the two ways, the most popular one. One is the in-place rebuild. So we can truncate our current read model, and then we can reapply all of those events that we had with the new logic and fix our read model. But of course, in-place rebuild is not great because we will have some downtime, and if we need a lot of events to rebuild this this projection, then it may take time, even weeks sometimes in the worst case. So sometimes it's good enough, but typically we would expect to get a blue-green rebuild. So blue-green rebuild can be done in a way that we are still keeping this potentially wrong read model, which might not be so huge issue because, as I mentioned, on the right logic, we are always using events to rebuild the state. Then even if someone got the wrong information, then this right model logic and optimistic concurrency and other guarantees will help us to keep the strong consistency and to not get the wrong updates. but we can create in parallel the new empty read model. The old one will still handle the queries, and when we are then when we can apply each event on this new read model, and after we applied all of the events, then we can switch the querying to the new read model and make the previous one obsolete, potentially truncate it or archive it. So let's have a look on how to do it with the EventStoreDB. So let's go back, and this logic will be exactly the same for both approaches. So whether we are using the functional way or non-functional, this will be showing the same case. So let's have a look on the subscriptions and how the subscriptions are looking like. So the EventStoreDB subscription have the main method. Let me find it. Yep, it's here. So we may say to EventStoreDB that we would like to subscribe to all, for example. And let's get back to the slides for one more moment, and discuss how positions in EventStore look like. So as I mentioned, we have each entity or each aggregate will have a dedicated stream, and all of those events will have an auto-incremented position. It's called stream position, and this will be a unique position within this stream. So as you can see, between those streams we can have the same positions. So, but that's obvious, like 1, 2, 3, 1, 2, 3, 4, to know in which order those events were registered. And then we have also allStream, which is just a unified, a global log. That's why it's named all log, because it contains all of the events from all of the streams. So it also have its own position. It's also monotonic, but it might contain gaps. Stream position is gapless. So if you are familiar with Kafka, then this position is similar to the partition offset. So you can use it to know what was the last event you saw and what was the last event you processed and applied on your projection. So EventStore, you can subscribe to the single stream. Then you would use like the string subscribe to stream method, but I'm using to all because that's a default that I would recommend to start with. If it appears that you have too many events and you need to tune it up, then you might consider doing other subscriptions. But for now, let's say that we will be getting notification about each event that was recorded in EventStore. And sorry, let's make it a bit bigger, and we can pass some options to EventStore to EventStore. Like we can provide a position, and a certain position, the last position that we saw and that we applied. And this can be used, for example, on resetting our projection. So we can say that there is no position, and then we are starting and subscribing again from start. Or typically we would like to just say that that was the last position I know. So for example, if our subscription has restarted, then we should read the last position we know and use it to tell EventStore that I would like to subscribe from this position. And EventStore has two types of position of subscriptions. One is called catch-up, or the regular subscription, and then you need to maintain checkpoint on your own, and that gives you the benefit, and we will see that in the future, that we can store this checkpoint in the same transaction, for example, in the relational database transaction, and have the strong consistency also on knowing that either we process this event or not. And we could even, based on that, build the exactly one's semantics. And the other subscription is where EventStore is maintaining the checkpointing for you. It's called persistent subscription because we are persisting checkpoints internally. And for that, I would compare it to like a RabbitMQ with multiple subscribers. So it's implementing competing consumers pattern. So the good thing about that is that it can scale horizontally easily. However, the ordering is just best effort. So if we have retries, if the consumers are having a hard time, then you might get events out of order. If you are using subscriptions like the regular one, then you have the guarantee that those events you will get on in the order of appearance, and subscribe to all will guarantee you that you will get all events within EventStore in the set order. So that's a bit different than in Kafka, because in Kafka, to get that, you would need to have a single topic with a single partition, which might be fine for some cases, but I'm just using you to maybe give you some familiarity. And in the subscribe to all, we are also defining the listener, and listener is we are saying what we want to do with event. So it will just give you the resolved event, and we need to handle it somehow. So this handling is agnostic for EventStoreDB. As I mentioned, you can forward that to Kafka, to Rabbit, or any other queue, or you can build a projection based on that. So how to do that? At first, we need to know what's the event type for the specific event, and we can get it from the event metadata. See, get event type. Knowing the event type and mapping it to Java class, we can get and build the stream event. And after we deserialize this event, then we can publish that into internal event bus. So, and event bus internal, in my case, I'm just having like a really basic dummy implementation. This is in-memory bus, and I'm just publishing event together with its metadata. So metadata might contain event ID, stream position, the global log position, and event type. We can use it further on, for example, in the forwarding that, or etc. And this is also the place where Spring Boot is coming into with the help. And we can use the application event publisher that exists in Spring Boot. And application event publisher, if we publish event there, then it will search for all the event listeners for the specific events and then call them. So it's like broadcast. We are publishing event, and then all of the handlers for the specific event will be called. So in my case, I can use it to build a shopping cart list. So the shopping cart list will contain a short information about the shopping cart. So the ID, client ID, status, total items, and total price. And you might already notice that I'm using the Spring Boot JPA or an Hibernate annotation. So I'm saying that this will be a column, and this will be nullable or not, and whether I would like to ignore it or not in my return, and also entity annotations. So if you are familiar with the JPA, then that shouldn't be a big surprise, because I'm using Postgres database and Postgres as an example how to integrate with the relational database. So you can still use the Spring Boot repositories to update and query for the data for the read model side. But we will get back to that, but let's see how we can define our projection. So again, when we got a notification from event store, we deserialized our event, and we know that this is a certain event and wrap it with some metadata, then we can define our projections, and we can use the event listener annotation. An event listener annotation will tell that when this event was published to application event publisher, then this method should be called. And I created a basic wrapper to reduce the boilerplate for the JPA, and it's extremely simple. So I'm defined methods that are similar to what you see before. So add is taking an event and the function that states how to apply this event on this particular entity, so the read model. I'm also checking and setting using the versioned view interface, which is just saying that I'm saying the metadata. So I'm saying setting the position of the event. So the last known position that updated this specific view, and I can use it later on to make sure that I'm not applying this event twice. So I can define method that I will verify if the last processed position isn't already bigger or equal to the position from my event. And if it is, then I will just ignore it, and by that I will handle idempotency. We can also use the optimistic concurrency handling from JPA if we'd like to. But yeah, the add is really simple. We are just getting event and returning new view that we store in the repository. And the repository is just a Spring CRUD repository. And for get an update, at first we are getting the current state of entity using from repository. Then we are making sure that this entity exists. We are making sure that the event wasn't already applied on this specific entity. And then we are running the function that will apply changes from the event on this particular view. And then we are storing that as a result. And for delete, it's simple. We are just deleting the view. And if we get back to the projection part, so the projection definition, then we can see that if we get a shopping cart opened, then we are returning new entity that will end up as a new record in the table. For the get and update, we are saying that we are searching for a record with the shopping cart ID, and then we would like to apply this event, and for this case we would like to increase products count. So this is just a simple wrapper. We are just adding the quantity to the total count and price to the total price, similarly for decreasing, etc. And if we get back to projection, then for the cancelled, we can even delete this record because for example, we wouldn't like to see that in our list view. And if we have getting by ID query and we have a details projection, then we might define also there a list of product. So this is the details. And we can also have a list of product items which will land in a dedicated table. I'm using the join column to define one-to-many relation in JPA. And projection will look exactly the same. We will say that event listener, and see we are listening for the same event. So in this case, shopping cart open, and then we are returning the shopping cart details, and we are for the adding product item, we have a bit more logic because we need to know whether this product item already existed or not. If it existed, then we are just increasing the quantity. If not, then we are adding new product item, etc. But the logic is precisely the same. So if we were using other database like Mongo, Elastic, then we would use just another API. We could define another base class for projection, and even we could run the specific SQL statement to update, because we don't need to operate on objects. It's, if we'd like to, we can even run the custom SQL statement and call it a day. So projections, again, are just interpreting some events, creating new interpretation, for example, materialized view that we can store in database and integrate in the same way as we would do normally. So if we get back to our shopping cart service, then see for getting by ID to show the details, then I'm using also the handler, and it's also using the repository, and it's either trying to find by ID or find by ID, making sure that it's at the certain version. So it's also helping to handle the idempotency. I'm using for that if match and if not match HTTP header. So I'm encouraging you to have a look on that if you are not using those headers anymore. And for getting shopping carts, again, I'm just calling the classical paged API for repository, and I'm getting all of those read models from the Postgres. So the database that is much better for getting queries like multiple entities, etc. In the future, we might have also some read models built in, at least basic key value store in EventStoreDB. That's under discussion, but so far this is the pattern. So use the right model to run the business logic, store events within, and using the strong consistency and optimistic concurrency, then subscribe to changes and update read model in the dedicated and the database that is natively built for that. And in that regards, I hope that it's also showing you that you can integrate those patterns using like the classical approach. So, you know, JPA, Spring Boot, etc., and just replacing the parts where you would benefit the most out of that. And for example, in the shopping cart, you might keep, because you are interested in knowing all the details and all the history of the shopping cart process. But for example, inventory, like the product's inventory, might be just a CRUD module that you would just integrate together. And I'm also using here other things like from Spring Boot, like retry template. It's a really nice thing to just have option to, for example, retry until we get an expected version of the entity. That can be useful because we need to remember that we have eventual consistency on subscriptions, and long polling and retry policy might be just helping you to just cheat your API that it's synchronous. Of course, you need to be careful on that, but it's doable. And I'm also using the same retry policy for subscribe to all logic. And the last thing that I would like to show you about the subscriptions, it's that subscription to all, besides the internally using retry template when the subscription was dropped, then I'm also using the smart lifecycle from Spring Boot, which gives me option to run my subscription in the background continuously. So I can run this subscription within the same application as my API, or I can run it in a different. So if we would like to not put too much pressure on the same service. And with the smart lifecycle, I can say that when this background worker is started, then I would like to subscribe to my subscribe to all. I can inject all of those dependencies, event store client, event bus. When my application was stopped, then I would like to stop the subscription, and I can also provide some diagnostics like if this service is running or not. So if you have any questions, feel free to raise them. I would be happy to answer them as we go, but let's go to some final slides for this webinar. So event sourcing enables you to do time traveling, because you can get a certain set of events, apply them on entities. So for example, even our customer complained that they got wrong game, not the one that they ordered. So we can just go back in time, get the events from event store, and even apply them on our local representation, even write the test. And then we'll see that the guy, in fact, okay, he added Cyberpunk, but then later on he decided that he doesn't want the Cyberpunk because he prefers to play with the Witcher. So, you know, we can, in my opinion, diagnostics that we can get from event sourcing for us as developers, that's really cool thing, and that's one of the killer features. So I'm not saying that the business audit log, yeah, it's great to know that, because we can build a business model and get insights, but for us developers, that can be even more important to know what has happened in our system and understand that, and have a better debugging. And we are also getting auditability. So if we have a process that we are when we confirming card, then we are producing card confirmed event, then we are subscribing and running some other logic, like we are sending email, we are generating a pro forma invoice and then printing this invoice, then we can correlate all of those information together. And how to do that? We can use the correlation ID, so generate an ID that is specific for this process or for this request. So for example, when we are getting request confirm shopping cart, then we are generating the request ID, unique one, and then store it in the metadata in all the events. And having that correlation ID, we can know which events were stored as a result of this particular operation. So we know the whole set. However, that's not always enough, because we would like to also get in which order those events appeared. Because here it's much easier, because I ordered those events, those images on the screen, and we are humans, and we can also interpret more or less which one happened in which order. However, computers are not so smart. For them, all of those events are just an event, just a bytes. So we can store, besides the correlation ID, to know what caused, to know all events and all the facts that were generated by the specific request. We can also keep information what caused the specific event. So for this, for example, for card confirmed, we can store it as causation ID, the correlation ID of this shopping cart confirm shopping cart command. For the card confirmation email sent and proforma invoice issued, we can store it as a causation ID of the event, of the card confirmed event. And for proforma invoice printed event, we can store as a causation ID the previous event that caused that one, the ID of proforma invoice issues. And based on doing the simple stuff like that, we can build a tree that is showing us in which order and what was caused by that, by which. And if we join those pieces together, then we have the full spectrum, so correlation and causation. So, summary. I hope that I managed to show you that event sourcing doesn't have to be so revolutionary. You can still continue to use your favorite frameworks, if the Spring Boot is, of course, your favorite framework. Um, you can join that event sourcing with the classical approach. For example, run the business logic with event sourcing, then apply those events on relational database, or you can use event sourcing only in some modules, and for the other use totally different approach, and then just integrate those modules in the same way as you would do for any other architecture approach. So I hope that you have fun. You had fun on this webinar, and you will play with event sourcing and EventStoreDB. And that's all from me. If you have any questions, that's the right moment to ask them. If not, then you can contact me through my email, which is oskar.dudycz@eventstore.com, or you can find me on Twitter, which is oskar@net, or you can go to our samples. As I mentioned, they are already there. All of the things that I show you are already there. So thank you for being here. And yeah, George wrote that at this point in time, I'm overwhelmed. I would need to rewatch and check out the code to fully understand. I hope that this is a positive overwhelming. I know that this is a big portion of information within 1 hour and 40 minutes. So don't worry. I was also overwhelmed when I first saw event sourcing, but I hope that at least I increased your curiosity and you would play with that. When you do, feel free to reach me and ask me and send me a feedback. If you have some other concerns, and not only George, but any other of you that are watching this webinar, I'm here to help you. So I would be happy to clarify and clear confusion or answer questions. And yeah, thank you a lot. Thanks, George. I'm glad that you learned a lot. I hope that the others also did. So if there are no other questions, we can call it a webinar. And yeah, check our database, check event sourcing. It's not so scary. It's you will have fun. And that's all. Thank you a lot. Bye.